Hi, my name is Vahan Davudyan. I'm a physics experimentalist for 30 years. And in fact, I have already uploaded 36 theories in this last 6 months to YouTube. And then now, today, I don't have any theories, but there are new concepts, the small concepts. So like 1 minute, 2 minutes, and so on. So I decided to combine them all together and make it some science. And then, in fact, first of all, I'd like to thank YouTube for this wonderful opportunity for us. We can upload our videos, some other people can upload their videos, and we can exchange views, and then we can see all those science movies. And in fact, YouTube is doing a fantastic job. It's like a so comprehensive network. It's like a university, free university, so everyone can learn, everyone can express their opinion. We appreciate that. And in fact, I compared YouTube to synapse, which is junctions in a human's brain, which is connecting billions of neurons together. That's exactly what the YouTube does. And in fact, today I don't have theory, but these are facts. These are all my observation for 30 years in physics and then nature and so many other things. You know, I had almost like 60, 65 of them, so for the time being I chose like 35 of them. And there are small concepts, but you would love it because these are the things we encounter in our daily life, in routine every day almost. Sometimes we ignore the fact that what we're doing is the laws of physics. For instance, the first one, my theory, is a golf ball. And imagine all you know what the golf ball is, but when you touch it, it's not smooth. So you should ask the question, why it's not smooth? It can travel much better. On the contrary, no, it's got dimple on it. And in fact, the old days, it wasn't like this. And then they realized that little dimples is creating low pressure. Whenever I picked up this, and then immediately my mind goes to the supersonic, and then Mr. Richard Whitcomb, one of the greatest scientists in the United States, you know, who discovered it was called area rule, and that was amazing how much he worked, and that was so complicated that finally he found the problem, because airplanes those days could not travel the speed of sound, but Mr. Richard Whitcomb came over and find out that, you know, he can do it. And in fact, ordinary airplane is like this, and you can see the fuselage is just straight like this. And these are like commercial aircraft, you know, for the passengers and so and so. But overall, they cannot exceed that limit they wanted. So Mr. Richard Whitcomb was so confused, and then he had so many experiments. And I remember one time he was so good, he replaced the entire fuselage. It didn't work. And then he was invited to a restaurant. His friend says, Richard, would you like Coke? He said, yeah. And then immediately his mind was prepared. He says, Coke bottle. So what it was, the airplane fuselage is supposed to be curved here. So that is causing low pressure. And then he solved the problem. And imagine since then, it was amazing. I mean, he changed everything in aerodynamic and things like that. So my idea for this small concepts is not to teach chemistry or biology or physics or some other things. My main idea here is to activate your sense of wonder, so you can see, if you see something, you have to analyze it. And in fact, I came up with a fantastic idea. This is called How to Learn Laws of Physics in the Streets. That is the best, it fits in my idea, and now I have 35 of them today. And I'm hoping by the time I explain, each one is like 1 minute, some of them less, some more. But you will learn that, you know, whatever we do in our daily life, we are conducting laws of physics. And then I would appreciate if you would listen, and then you can see how easy it is to remember. One time you see this golf ball, say, hey, remember what Vahan said? These dimples, there's a purpose for it. And in fact, They travel so good. Some of them are like 125 dimples, some 300. But overall, you can see it's not as smooth. That makes a big difference. So whenever they get the club and then they hit this ball, it's going to go straight exactly the way they want it. Well, of course, the mass is also important and so on. And second one is competition. Why competition is so important in our life? And in fact, I drew this so you can see it's a track and field. So you can see there are 1, 2, 3, 4, 5, 6, 7, 8 lanes. And then imagine, I'm sorry, one runner is over here and there was no one here. And that one runner won't be able to do his best. The reason why, there's no competition. There's no one on lane 2, 3, 4, 5, 6, 7, or 8. So what if there is one runner here, one here, one here? So now we got 3 runners. Competition is so fierce. What if we have 8 runners? That is going to be 100th of a second. So that is why the competition is so important in our life. And imagine without the competition, we never know how good we are. Mr. Usain Bolt is going like 9:58, which is for the human being with that physics, it's almost impossible, but he did it. But imagine, I remember from 1960s, they did 9.9, 9.95 or something like that. Second, but the humans cannot go beyond that. But overall, the competition is so important. And always remember, if there is no competition, you have no idea how good you are. Can you beat someone or they can beat you? What if there is a wall between 1, 2, 3, 4, 5, 6, 7, 8, and then these runners won't see each other? And guess what? The result is going to be completely different because number 2 doesn't know how he or she is running. And I have seen sometimes they do fraction of a second, which is unbelievable. I would say maybe some of them, they can win the gold with maybe with 1 centimeter. Okay, number 3 is the history of scientific breakthroughs. Sometimes curiosity is amazing. And in fact, Hans Lippershey, he was lens maker. He was not scientist, but he was fantastic from Dutch. And he was a lens maker. And imagine, he was doing amazing job. Well, of course, there's another one I have to. His name was Lee Van Hook. He had no education whatsoever. He invented the microscope and some other things. He was doing lenses all day long. But Mr. Lippershey had a boy, and nobody knows how old he was and what his name was. By curiosity, that young boy picked up 2 lenses, and then he put it on his eyes. He could see that, the wall is coming closer. That was probably a breakthrough in science. And that was the greatest invention ever. And then Galileo was in South Italy vacationing. He heard about that and he was a fantastic scientist. He said, oh, no, I don't have to vacation here. I have to go back home. And in fact, they called that a spyglass. He went home and Galileo did not invent it, anything like that. But, he did a fantastic job with, telescopes and some other things. And then he realized, and what would happen if that young boy did not get 2 lenses? We would not get all these planets, these stars and everything else. So it's so important that, some people are so observant. They can see these things. In fact, Robert Wagner, he was a weatherman from Germany. He was an amazing scientist. And one of these students, 1 or 2, they said, Mr. Wagner, if the Africa, we push the Africa in the other continents, will fit. He didn't pay attention, but he knew. And then finally, he came up with the Pangaea. And imagine a young student, nobody knows what their name was, but they knew. Sometimes some students are extremely smart. They can tell exactly. I mean, they have fantastic scientific concept in their mind, and they can say everything. Like, Italian anatomist, his name was Luigi Galvani. Okay, he was fantastic, anatomist, and then doctor, and then they were dissecting a frog, and finally, that was not his idea. One of his students, by accident touched the frog with a copper, and then dead frog twitched the thing, and they had no idea why the dead frog could do that. And then, by mistake, he said it's animal electricity, because, in fact, to be honest with you, I give 50% to Mr. Luigi Galvani and 50% to Alessandro Volta. But Volta was physicist, and he came over and said, Mr. Luigi, that is not animal electricity. That has to do with the metal. And imagine how smart Volta was. At that time, electronegativity was not even around. And then we would be like another 100 years, Mr. Linnaeus Pauling would came over, and he did the Pauling scale, because the copper electronegativity is 1.9 and the zinc is 1.9. He devised this table with a great precision. It's unbelievable how he did it. But what I mean, Mr. Luigi Galvani did half of the job, but half of the job did who? Mr. Alessandro Volta. And in fact, when I was in high school, Louis Pasteur was my ideal. He was my role model and so and so. And then in fact, I had the, silkworm, and then I would go get, and then feed them, and that was a good hobby for me. And I heard he was a great scientist. And once he said, the chance only favors prepared mind. That is amazing. I wrote it in my science lab. Chance only favored the prepared mind. And there was another one. And let me see who this man is. Robert Wagner, and then, Hans Christian Ørsted. He was Dutch physicist, fantastic. One time he was in classroom, and the student realized we turn on the, on and off, the compass is going crazy. And he was amazing scientist. He waited 3 months. He translated in 17 languages, and finally, after 3 months, he published. But as Mr. Louis Pasteur says, his mind was prepared. If I turn on the compass and then it's going crazy, I couldn't even tell what that was. But Mr. Hans Christian Ørsted was physicist. So this is another thing that why some people are so good, and then they know the history, and And then number 4 is for the human body. And imagine, always, my arm is like a lever, my arm is like a ratchet. And imagine this is my arm, and then when I go like this, see, this is my arm. Well, of course, the advantage for the human being is I don't have to change this from clockwise to counterclockwise, because humans' arm can go front and back to the sides. It's so versatile. And imagine what will happen if they tied up my hands like this. I won't be able to walk. I can walk, but barely. I can't even run. I cannot run because, my hand is a ratchet. It's like a wrench. It's causing torque on my body. And imagine my hand is like a lever. So imagine every part of your body, you are performing laws of physics. And in fact, I had to draw this. So you can see, this is my shoulder, and this is my elbow. And well, of course, it's not the branches or my fingers. And then you can see, this is going back and forth, back and forth, back and forth. And it's causing torque on my body. So the human body is amazing. I mean, how could we have all these things in our life and then we don't even pay attention that, your hand is a wrench. And in fact, it's a huge wrench. And the best example is if I want to run, I won't be able to run like this. The reason why, I have more inertia because I'm causing torque. But my body is axis to rotation and my arm is long, so I got more inertia. But when I run, what you do, you go smaller. So this is going much faster, much faster. You have never seen a runner run like this because they won't be able to do it because of inertia. So imagine, human body is amazing. Everywhere we can see laws of physics. When I was in elementary school, I remember we were so adventurous. We would jump from 2 meters down, 3 meters down. And one time, I asked my, science teacher, why our spinal cord is not getting damaged. He said, wow, that's the best question. And it was curiosity. When I jumped down like this, and imagine, this is a spring over here. Your knee is like a spring, it's like a joint spring or shock absorber. And imagine if you jump from 2 meters, 3 meters, and then you don't bend your knees, your spinal cord is going to get damaged so bad. So imagine our body is always like that. It's prepared to meet everything. And sometimes knowingly or unknowingly we jump and we never know, we just open our knees immediately. So what happened? This is the floor, is exerting force, but it's not going to go to my, see, it's like a shock absorber. It's going here and then the direction is changed here. So that is the key. That is the key. If we don't change the direction of the force, what will happen? We're going to get damaged. This is another example. So this man is a young man, you can tell. Then he is using his arms as leg and like springs. So what he does, this part is like his knee, so he's bending and then pushing. Those springs are helping so he can get this big load. I have no idea how this one is. Sometimes you're in the street. Why did I tell you that, I love this title? To learn laws of physics in the streets. Can you do that? Of course. When I love the construction sites. When I was a young boy, I would go to the construction site, and then one day I remember I asked one of these guys, what are these anchors? Sometimes it's sprayed, sometimes it's not. And then he explained at that time, I was so young, I couldn't tell. And then I realized the curiosity is good. Next time you pass by a construction site, take a look. Those anchors are open. This is one of the most important laws in a physics. First law, inertia. So imagine this boom is huge, and then you can compare this to a lever. If I push this lever, it's going to tip over. The reason why this crane is not going to tip over, the reason why they're extending these anchors, so there is no way this boom, it doesn't matter how heavy load they have, it's not going to tip this over. So these are the laws of physics you can learn in the streets. Overall, sport was part of my love. I love the sport. It was, part of my passion and everything else. I remember I was 13 years old, and then I heard one person, this is called straddle, is a high jump styles. So straddle was old, very old, and then imagine, finally, oh, they did their best, and they could not exceed 2.34 meters with the straddle. And then I remember I was in high school, his name was Dick Fosbury. He was genius in physics and everything else. Dick Fosbury came over, and imagine how much he improved. From 2.34 centimeters, he improved to 2.45 centimeters. And in my opinion, it was great. He got the gold medal in 1968. That was a big deal, but the big deal was he solved a problem in a human body that, if you torque your body in a different way, you will be able to improve the laws of physics and everything else. And imagine, you go like maybe 10 or 12, I'm not sure how many, they run. Then what happened, they go over the bar. But there is an important point here. His or her center of gravity is below the line, not above the line. Because unfortunately, every time we fall, technically, that Earth is causing torque on our body. Wherever myself, like in my the gravity is here, is causing me. So they're causing torque, and imagine, they did it, and it's been from 1968 since then. There is no way some other people can come over and beat Mr. Dick Fosbury, because this was scientific, this was good, and I'm glad he did it. This is the moment of inertia, because most of you have seen this before. Like, when I was really young, I was saying, well, why do they have a stick? At that time, I had no idea what laws of inertia is. Why? The stick is small, it's going to cause torque on his body. And imagine, some people even crossed Niagara Falls. That is incredible, because see, they used laws of physics. The longer the stick is, the more inertia you have, and your body, and then the gravity is not going to cause torque to your body. So the further is from axis of rotation. See this man over here? That is the axis of rotation, and the further the sticks are, you're safe. You're not going to fall or anything. This is another crane. Well, of course, I have to explain. Sometimes you go to construction sites, and I want you to be observant. That is the way you learn laws of physics. Well, of course, the other one, maybe in half an hour I will explain that, is called truss. This is amazing invention. This triangle, you may overlook, well, it's a triangle. No, triangle is the only shape. It doesn't matter where you apply the force, it's not going to get crushed. So if you have circle, it's going to get crushed. If you have like rectangle, it's going to get crushed. If you have anything, it's going to get crushed. But the truss or those rectangles are the only one they're not going to get crushed. I remember when I was in Eiffel Tower, that was a long time ago. And then I did ask myself, why everything is triangle? I was in airport, the same thing. And then I was in bridges, the same thing. And some bridges are so huge, and this is the only way they can do that. So imagine, if I replace the cranes, boom, with a tightrope, it's going to be the same. So overall, what we do, see, this truck is huge. But what it does, instead of one, they have two. Well, of course, it's always laws of physics. They have to calculate, they have 4 tons here. They have 10 tons here. They have 20 tons. They have to hoist that 20 tons so they can spread this. Imagine, it doesn't matter if this truck is 50 ton, is going to tip over. The reason why? This is axis of rotation. That must be spread. And I remember when I was so young, maybe 13, 14 years old, and then my brother told me, you're good, you're macho, you can play box and so on. So I said, okay, let's go play. And then they gave me these things, I had no idea, and he was my coach. And then first round, I was knocked out. And then I asked him, brother, what happened? You didn't tell me so bad. I said, no, you know what? You have to open your feet. And then my brother had no education at that time. He didn't know. I said, why do I have to open? And because he said your center of gravity is less. And imagine when you open your feet, at least 20, 30, half a meter, your gravity is going down. The less, the closer you are to the ground, the more, you're not going to get damaged. Okay. I used to work in Denver, an international company called John Crane International, and then I worked at 13 years for specialist, mechanical seal specialist. And I remember we were getting like UPS and FedEx, almost like 100 packages a day. And then we had another man, he was so interested in science, he was always asking me questions, and I love that man, and I told him always to keep asking me questions, John. The reason why, if you're asking me questions, I remind myself, and then I go investigate more, and then I can tell you. And then we would learn a lot about the physics and so on and so. One time I remember in Denver, Colorado, was -6 or -10. So I received a big box, and in fact we were dealing with metals. It was stainless steel, very expensive, and then they were not magnetized, they were special, but overall they were metals. And then when I picked up one box, it was like 25 kilograms, and then when I put it down, the cardboard was so, normal. It was wet a little bit and the damp a little bit. When I opened and then I touched the seal, it was mechanical seal, it was frozen. And immediately I said, Vahan, these physicists are right. This is called mobile electrons. In fact, mobile electrons are so amazing. If there is no free electrons in electricity, you won't have any, AC, DC or whatever. And at the same time, if you have a conductor, like a metal, well, of course, we have copper, gold, and silver, and so on and so. Each metal is a little bit different. Like, copper conductivity is much better than, the poorest, I would say, is a lead. And then I realized that physicist, I read the book, he was right. So these are the mobile electrons. It's despite the public perception, the heat is not the only thing which is getting transferred. Cold is the same way. And then when I touched that, and believe me or not, it took about 20 minutes, it was back to the room temperature. So this is the way you learn, because always I think these are important in your life. When you pay attention, it is so important. Most of the time in our life, we walk and then we run and so on and so. And in fact, one of the most important laws of physics is called thermodynamic. And as a matter of fact, the entire universe is governed by second laws of thermodynamics. And we do have a lot of laws of physics we're doing every day. I remember at Regis University, that was 15 years ago, someone asked about my second law. I said, it's just easy. I give you an example, so easy. You have a cup of coffee, put your coffee on the table. Okay, I put my coffee on the table. Touch that, it's almost hot. 96, 97 Fahrenheit. And then I said, after 20 minutes, touch it again. It's not going to be hot anymore. I said, you are performing laws of thermodynamics. If you put your coffee or tea on the table, it's going from hot to cold, because at that time when you boil the water, the kinetic energy, it was, the jumping back and forth, hitting each others, and then, kinetic energy caused that to boil, and then that had extra energy. But where does that energy come from? From the electricity and some other things. And in fact, they did understand this. This was a simple thing. So you don't have to, always you have to compare to see how the laws of physics work. Sometimes you get up in the morning and they say, well, let's see how Mr. Ampere was doing. And imagine you plug in your coffee and you have to transfer quintillion, 18 zeros per second to get your coffee. Well, sometimes you can have 6 minutes, sometimes 5 minutes. And imagine you have to have so many charged particles, quintillion. And imagine 1 minute is 60. 60 times 6, 360. So it will be 360 quintillion charges. And then you have your coffee. And then, wow, is that so many charges? That's beyond your imagination. And then you go, start your car, and then put the gift or whatever on the passenger seat, and then you go in the street, you drive back and forth, and then you accelerate is going backward, decelerate is going forward. You go to the left, that gift on your thing going to the right or left. And then you realize you are performing laws of inertia. That is the way you learn. And then you analyze, okay, why this gift on my passenger seat is going forward and backward. And I remember when I had huge ball, I put it there, it was going crazy back and forth because the friction was less. But I had the same weight, I put it in a square box, it didn't happen. And imagine how you can use entire solar system at your disposal. Sometimes you don't think of it. When you're driving, your car has planetary. Let me show you. See, this is planetary gears, and in fact this one in the center is called Sun, and these are the planets. Well, of course, there's a ratio always. And then most of the time, 99% in cars, because I took apart, God knows, 20, 25 years, all these things. There's another one comes on top. So this is advantage 3 times. So the ratio is 3 to 1, which is getting mechanical advantage. There's another one comes on top of this, and then it says 3 times 3, 9 times, which is good for the cars. But overall, I had, drills and so and so. These planetary ones, the torque is not as good as the ordinary ones. I'll show you in a minute. Because see, these are called planetary gears, and this is great invention. And next time you realize you're driving, you have the entire planetary system at your disposal. By the time you get to work, you have traveled the universe. So, wow. And then you pat on your shoulder and say, hey, I'm a physicist. See, because you're using planetary things in your... Okay. Let's see. Let's do this one. This number 9 is a Baghdad battery. Sometimes the humans could not do reverse engineering. At that time, the science was not good. But I reanalyzed, I saw this. It was in a copper, and there was 2 metals. That is the way you have electronegativity, because even if you have 2, then stick it in a mud or something like that, water, you can get 1 volt DC. So Baghdad battery, they discovered it was 4,000 years old. But did they know that, this is electricity? Maybe no. And then I think what happened, it just accident, they had vinegar and they had no idea that was acid. The more hydrogen you have, the more electronegativity you get. And they don't realize that, that battery was, something that it could create electricity, but they didn't know. But unfortunately, all these origins of all these scientific breakthroughs are shrouded in a historical haze because nobody knows, and there was no writing at that time. They had no idea what that was. So this is my guess that, at that time, they had vinegar and then they had copper and iron. They realized, if they put it in their mouth, they can a little bit, it just burns a little bit. And they had no idea it was electricity. This is my favorite one. It's called Golden Gate Bridge. See, a few minutes ago, I told you guys that, if you're observant, you learn. I saw this like 43 years ago, the first time. I remember my friend was a fantastic person. He said, Wahan, you do your investigation, everything, don't worry, we can be here all day long. And in fact, we stayed in San Francisco all day. You touch those cables, still, and then you realize they are not straight like this. They are twisted. And then you should ask yourself a question, why? Those are still wires. They could have been just thick wires like this. But see, imagine, and I have never seen this any book to explain this. The reason why they're twisted, see, this red is supporting the blue is supporting all the way, and there is no way. But the most important laws of physics is, the weight is over here, is exerting force. This is not going to go straight down. It's getting twisted. And imagine, I did it for 1 meter, it was exactly 10 centimeters more. And imagine for 1 kilometer in San Francisco, they must have at this, because when it's twisting like this, you get more wires. And there is no way that they are going to snap, because this is the laws of physics. This is the way they work. Because the old days, they said, well, there's no way. Because imagine, those old days, they used to use, ropes, and there was no nylon at that time anyway, but the steel is not going to snap because each one is supporting individually. And next time someone asks you why the cable is twisted, because the force is not getting straight down, it's getting twisted, and twisted. My grandma was an amazing person, and then I was 6-7 years old, and then he showed me this invention is almost like maybe 1,000 years old. Let me show you. This is called a spindle, and then this is called distaff. So what they did, this is like a cotton or other thing. And how did they come up with the genius idea? So my grandma had, like a spindle like this. It was wood, and then my grandfather was a priest, and then he was a good handyman. He just carved everything. He put it exactly like like this, a spindle. And then my grandma was getting this, and then I was asking her, why do you have to twist this? He said, my grandson, if I don't twist this, they're not going to last. And I remember when they were twisting this, and then I realized that, that cotton was so good. I mean, there was no way I could snap it. And then I saw one day they were doing like a carpets, they were doing jackets and everything else. So in fact, this twisting thing, it's not new. It's been around millions of years. God knows how old this spindle is, because they have seen it in Aztec and some other. But unfortunately, the history doesn't tell us. But this is the way I saw my grandma. And then I went to my physics teacher. I said, what can we do? He said, Vahan, the best thing is throw away that wood and get, like a metal, aluminum. I said, my grandma is going to get mad. No, I can't do that. Because he was right. I could get the aluminum, and then the angular acceleration would get more and more and more. This is the thing I was telling you guys about a few minutes ago. This is a great invention. This is called thrust. The first time I saw this at Eiffel Tower, and then I was amazed. So I had to go ask an architect why. I said, yeah, because see, there's a reason why. And imagine, you have force over here, it's not going to get crushed. You have force over here, it's not going to crash. Force over here. This is the only way you can have those bridges with huge spans. They're not going to get crushed. And then I can see all the construction sites. Some of those, cranes are like 50, 100 meters high. And it's amazing how good they are. And how could they have huge loads and they never crumble? And nowadays, they even came up with something new. They had another bar in the center. And then I asked them, what's it? Because this is 100%. Of course, this is 100%. But when they add another one, and then it's going to be more. I show you, I have some over here. Let me see where they are.